Hello AP Chem students and welcome to topic 5.10, multi-step reaction energy profile. So the learning objective for today is 5.10.a, represent the activity energy and overall energy change in a multi-step reaction with a reaction energy profile. So here we go. So reaction profiles look a little different for multi-step reactions, but the overall key features are identified in the same way. For example, let's look at the multi-step reaction for the addition of hydrogen chloride to 2-methylpropane. So here's your overall reaction. You don't really need to dig into this much, but you do need to know here that this overall reaction actually occurs in 2 steps. So 1, 2. Okay. So we've looked at reaction profiles for a single step reaction, but it makes sense to you now that we've looked at mechanisms that the reaction profiles might look different. And they actually look like this. Okay. So the reaction profile clearly demonstrates the 2 steps, 1, 2. Okay. So then we're going to use this graph to identify several different things. So you're going to identify the transition state, the activation energy for the overall reaction, the rate determining step, the overall reaction energy, and then is this endothermic or exothermic? So I'm going to go through the answers on the next slide. So if you want to try them ahead of time on your own, please pause this video. So here we go. So let's start with number 1, which is the transition state. And there's actually 2 transition states on this graph. So you've got transition state for step 1 and your transition state for step 2. Okay. Then we have an activation energy for the overall reaction. So the activation energy is going to go from the reactants to the highest peak here. And then in AP chemistry, we're pretty much always going to see that highest peak at your first step right here. Then we're going to talk about the rate determining step, which is also going to be the step with the highest peak. Okay, so then you have your overall reaction energy, which goes from your reactants to your products. Okay, so this is that difference. So that's your overall reaction energy. And then is this endothermic or exothermic? This is going to be exothermic because your products are at a lower energy than your reactants. And we're going to get much more into that when we get into Unit 6, which is thermochemistry. So that's coming up really soon. And that is it. So really, you just need to be able to draw a reaction energy profile with relative features that match the given conditions. Now, I do want to say that if they tell you that the activation energy of the second step is higher, then you would need to make sure that this hump here is lower and that this one is higher. Now, in terms of determining the activation energy, then I would expect probably that you would see something that looks more like this, where the activation energy is for the highest activation energy is in the first step. And then if they ask you to determine the overall reaction energy, then you would just subtract here. And again, we'll talk about that more when we get into Unit 6. And that is pretty much it. So make sure that if you have a 2-step mechanism, you have a double hump graph, and that you have your heights, your relative heights correct, and that your relative level of your products based on they're lower if it's exothermic and they're higher if it's endothermic is correct. You'll be able to get these questions right and earn yourself some points. I'll see you soon when we'll talk about catalysts.